Hello, class. Today we are going to be talking about calculating the mean, median, and mode, but we are going to be doing so if it is a large set of data where the data repeats itself. So a lot of people have the same number. And so the example I decided to analyze today is the age of students in the upper school, because a lot of students in the upper school have the same age. I think a lot of people in this class would have the same age, because I'm guessing that most people in the class are either 17 or 18. So you're going to have a lot of repeats of data. So instead of like going 17 plus 17 plus 18 plus 18 plus 18, which just gets very, arduous, and it's easy to mess up, because what if you do one too many 18s or a couple too few 18s, you'll mess it up. If you have a lot of repeat data, you're going to want to utilize multiplication. And so we're going to talk about how to organize the data, and also what's the easiest way to calculate the data centers, in other words, the mean, median, and mode. The mode's going to be the easiest part because of the way we organize the data, but the mean and the median are going to be a little bit trickier, specifically the median. And so this is 14B.2 in your packet, but let's go for it. So this, here, let me change so we can see. This is a table of the age of all the students currently in the upper school. So we have one 13-year-old, no 19-year-olds, so 28 14-year-olds, 79 15-year-olds, 75 16-year-olds, 91 17-year-olds, big junior class it looks like, and this will include some seniors as well, and then 61 18-year-olds. So what we're going to first do, and this is going to help us with calculating not only the median, but also the mean, is calculate our cumulative frequency. Now, cumulative frequency is the amount of students that are that age and younger. So the amount of students that are that age and younger. So when I calculate the cumulative frequency for 13-year-olds, only one student is 13 and younger. But if I'm then going to calculate the number of students 14 and younger, what I have to do is take the 1, add it to the 28. So you're adding 1 to the new category, so the 14-year-olds, and then that's going to give you 29. So there's 29 students that are 14 and younger. So again, 29 students that are 14 and younger. So the cumulative frequency tells you the students that are that category and younger. Okay, so let's go next one. You do 29 plus 79. And again, that will tell you the number of students that are 15 and younger. So 29 plus 79, that's 108 students that are 15 and younger. So 108 students that are incapable of driving. So that would give you a sense of number of students that can't drive to school, for example. Just, a little bit of information. Then if we take that number, add it to the 16-year-olds, that'll tell you those that are 16 and younger. So example, those that are legally unable to watch a R-rated movie, for example. So that's going to be 183. And then if we do that number plus 91, that's going to be 274. I'll just get rid of this little thingy. Oh, that was interesting. Let's delete. Oh, I don't think I want to delete the cell. No. Huh. Let's undo. Undo. Okay. Undo. Okay, so I get 274 here. So we have 274 students that are not legal adults in the upper school. And then if we add that to our 61, that's going to tell us the number of students in our upper school, 335. So what going to the bottom of our cumulative frequency chart here, or this column of our chart, tells us is our N, which is our total number of students. So that is kind of exciting. It gives us our total number, which we know is useful for our mean. So if I go to calculate, we're going to say, let's find the mean, median, and mode of our data. So if we're going to find our mean, median, and mode, if we want to start with our easiest one is our mode. Our mode is our data point that occurs most frequently. So we can just simply look at our chart to find our mode, and we can see our mode is going to be our 15-year-olds. So 15 years old is our mode. Oh, wow, that's a rough one. That's spelled old, right? Undo, 15 years old. That's our mode right there. That's just what occurs most frequently. And notice that we can just read off our data. It's our 15 years old. And then if we want to do the mean is the sum divided by the number of students in this case. So finding the sum, you wouldn't want to write it all out because that would be super time consuming. So what we're going to do here is utilize multiplication. So that's going to be our friend here. So we just have one 13-year-old. So that's 13 years old times one person, plus we're going to have 14 years old, and we want to count all the 14 years old. So that's going to be times 28, our frequency. So that's how many 14 years old there are. So I'm just kind of looking at my chart here. It's 14 times 28. So we count all those 28 14-year-olds. And then so that's in place of going 14 plus 14 plus 14 plus 14, adding all of them up, because that would just, to write all that out or to type all those 14s in the calculator would just be time consuming and error ridden. The likelihood of us typing 14 wrong or missing one or having an extra one is very likely. So we're doing 15 and we have 79 15-year-olds. And then we are doing 16 and we're representing all 75 of our 16-year-olds. And then we're doing 17 and we're doing all 91 of those. Those are juniors or seniors. And then we're doing our 18-year-olds and all 61 of those. And then we will take that number that represents the sum of all the ages of all of our upper school students, and we're going to divide that by the total number of upper school students. So this is where our cumulative frequency comes in very handy, because we know there's 335. So I want you to take a moment, use your calculator, and do a calculation. So you'll do 13 plus, and you can do all this on one line, 14 times 28 plus, and please grab your calculators if you haven't done so already. If you want to grab one from the cabinet, you are free to. Just please be sure to return that. Okay, now make sure to hit total, so enter when you get it all in there. Now I'm going to check. It's nice to have a calculator which shows what you entered, so you can kind of make sure you didn't make an error. I got 5,435 is my sum, and I'm going to divide that by 335, which is our total number of students in our upper school. And this will really tell me if I have a good average. My average is approximately, or my mean it is approximately 16 years old, 16.2 years old is the mean. And in your calculator, mean is X bar, just to let you know what they use to denote it. It's X with a bar over it. That is the notation. So each age is listed as like X1, X2, X3, just to denote all the ages. We'd have all the way to X335, and the mean would be X bar. So that should be our mean, if I did not mess up the calculation. I'm just kind of rechecking through it all. And it is, in my mind, fairly likely that it is a 16-year-old. That's kind of the middle of our data here. You know, you turn 16 roughly halfway through your sophomore year. And, you know, we still are not light on our 18-year-olds, but, you know, not all of our seniors have turned 18. So I have 13 plus 14 times 28, 15 times 79, 16 times 75. Yep, I think I got it. So, yep, that is our mean. And so to calculate the median, it would be absolutely insane to write all these out. So when we think of our median, I want you to picture all of the students in the school standing in a row according to age, kind of shoulder to shoulder. So you would have, for your median, you would have, first off, your 13-year-old, your 13-year-old freshman, and there's only one of them. And then you'd have your 14-year-olds, and there are 28 of them. So there are 28 of them, 28 students here. And then there are 15-year-olds, and there are going to be 79 of them. And at the top, because I calculated the cumulative frequency, I know cumulatively how many people. So far, this from here to here, at the 13, I only have one person. Now I have 29 people. So far from here to here, this is my 108th person, 108th person. So like the oldest 15-year-old right here, my oldest 15-year-old, the last 15-year-old is my 108th person. That says 108th, I'm sorry if it's tiny. So that's my 108th person. So what I have to figure out is what person is the median person. So what person would be exactly in the middle? So to find that, what I have to do is take the number of people, and divide it by 2. And that's going to be my middle person. That's the person that would be standing in the middle of that line. So I have 335 people divided by 2, and I get 167.5. So my 168th person is in the middle. So because this was odd, you just round up, and that's going to be the middle person. If it's an even number, it's going to be between that person and the person after that. So it'll just be between that person and the person after that. So in this case, because it's odd, you just round up, and it's the 168th person is in the middle. Okay. So if it's a fraction, which will just be 0.5, you just round up. So far, the 15-year-old, the oldest 15-year-old is the 108th person right there. Okay. So now if I go to the 16-year-olds, there are 75 of them. And so looking at my cumulative frequency diagram, that takes me to my 183rd person. 183rd person. And I know that from my cumulative frequency here, right here. So now I'm going to go full screen on this screen on my right so I can see it a little bit better. So my 108th person was 15. My 183rd person was my oldest 16-year-old. But my 168th person is the person in the middle. Well, we know the person in the middle is the median person. So what is the median? The median is 16. So in this case, we must have very well balanced data. So our distribution must be very bell curve-ish, you know, like that. Ooh, let's undo that. That seemed kind of skewed. Very bell curve-ish. In that our median and our mean are very close to one another. They might even be exactly the same, or very close to one another. I didn't get to, you know, how close the 168th person is to 0.2, but here I am. We know my mode is 15, but my mean is 16.2. My median and my mean are basically the same. And again, I calculated my median by calculating what person is in my middle. So the 168th person is in the middle. And I know which person is my 168th person because my first person was 13. My second through like my 28th person, 29th person was 14. And then through my 108th person was 15. Through my 108th person was 16. And I knew that because my cumulative frequency here, it shows me that basically 2 through 29, I was 14. 30 through 100 through 108, I was 15. 109 through 183, that was 16. And so that cumulative frequency tells me the ages of these number of people, which is why I filled out this chart. Okay. Here is your assignment. There is some reading in your book that explains this as well, kind of walks you through it. If you want to take a look at pages 388 through 390. That also has some worked examples if you want to read through those. If not, here is your assignment 14B.2. So you have the rest of class to work on that. Good luck. I believe in you, and I will see you tomorrow.